So first of all, we draw the angle. Now guys, because you're going to be tested online, and you can solve these extremely quickly if you know how to on a calculator, all our points, just about, nearly 90% of the points are going to be for the work you show, and you must show your work this way, okay? So turn that into a reference triangle, identify what your reference angle is. This angle here, it's either going to be a 30-degree angle, a 60-degree angle, or a 45-degree angle. So you need to know those angles in radians. 45 degrees is the easy one, it's pi by 4. And it's these two, it's just like so the 3 and the 6 are the wrong way around. 30 degrees is pi by 6, 60 degrees is pi by 3. So if this is divided by 4, our reference angle is pi by 4, which is 45 degrees. Now you have to know that your sides in a 45, 45, 90 really well. The sides are the same length, so we say they are 1. And then the r, the hypotenuse, would be the square root of 2. We're not in quadrant 1, so either x or y or both of them must be negative. And in this one, your x would be positive 1 and your y would be negative 1. When we come to do the cosecant, this is the angle that went in, and what comes out is a ratio of 2 lengths. And the lengths are sides of a triangle. So for a cosecant, it is r divided by y. So our r is the square root of 2, and our y is negative 1. So our answer is negative root 2. For the cosine of 5 pi by 3, it's the same thing. We draw the angle first, the angle being 5 pi by 3, which again is in quadrant 4. And this time our reference angle is pi by 3, which is 60 degrees. So this here is 60 degrees. So that's a 30, 60, 90 triangle. And your y would be the long side because it's opposite 60, not opposite 30. So that would be negative root 3. It's negative because it's going down. In quadrant 4, y would be negative. Your x would be 1, and your r would be in a 30, 60, 90. Remember the hypotenuse is double the short leg, 2 times 1. So let's finish this problem off. Cosine is x divided by r, so it's 1 divided by 2. Our cosine of 5 pi by 3 is 1/2. Now, does that make sense? That's positive. Would a cosine be positive in quadrant 4? Remember we did this on Friday last week? You can say angry Santa traumatizes children, or all students take calculus, and it tells you all trig functions are positive in quadrant 1, and cosine should be quite positive in quadrant 4. So that's fine that this turned out to be positive. Okay, let's finish off this warm up and try this one. This is really heading into what we're going to be doing today. Given that the cosine of an angle is root 3 over 2, graph a triangle in the correct quadrant and label all 3 sides with a length and a letter, x, y, or r, and let's work out what is the angle. So we've been given a cosine, so we've definitely been given an x divided by an r. We know that x is the square root of 3. So if I was drawing a triangle, that side length there would be the square root of 3, and the r is 2. Okay, so just draw a radius of 2. Here we go. So the third side, if you look at that, I hope you're recognizing that as being a 30, 60, 90 triangle. And this would be the short leg. So this would be 30 degrees. So that's telling me my angle in radians is pi by 6. But I haven't thought about this very closely. And there's a piece of information there that's covered up, and I still haven't corrected my presentation. It's the wrong thing that's written under there. It's not supposed to say theta is greater than 0. It's supposed to say that the angle is greater than pi by 2. So that can't be my right answer. I'm not in this quadrant. Here's pi by 2. My angle has to be bigger than that. Would this have worked? No, because that would give me x is negative root 3. So it can't be that, and it can't be this triangle either, because that would also have an x of negative root 3. This must have been a correct triangle. So the actual angle I'm wanting there is the angle that starts on the positive x-axis and goes to this terminal ray. I want that angle there. I've still got the same reference angle, that's still a 30, 60, 90 triangle with a reference angle. My reference angle is pi by 6, but I'm not in quadrant 1, I'm actually in quadrant 4. So I'm in quadrant 4 with a reference angle of 30 degrees or pi by 6. So the angle, the actual angle I want, this angle here, must be over 6. And in quadrant 4, you remember you're a little bit less than 2 pi. So double that 6, get 12, take it, make it a bit less. It'll be 11 pi by 6. That's the sort of thing that we're going to be doing with our lesson today. We're going to be given a trig function, and we actually have to find the angle or angles that would have that value for its trig function. Now, think about it for a second. If we're asking you to find an angle, and we're not allowing you to use calculators, the only angles we can ask for are either quadrantal, without a calculator, the only angles we can ask you for are quadrantal, so those are based on 90 degrees, 0, 90, 180, 270, but in radians, or angles from within a 30, 60, 90 triangle, or a 45, 45, 90 triangle, okay? And then depending what quadrant they're in, you'd actually have to work those out in radians for, like we just had there, a 30 degree angle there. You ask for this angle going all the way around. Okay, so that's what we're going to be working on today. So the only way we can make these questions hard is to try and disguise a 30, 60, 90 triangle or a 45, 45, 90 triangle. So let's first of all make sure that you know what the size of a 30, 60, 90 and a 45, 45, 90 are. 45, 45, 90. These two sides are the same length. We just say they're 1, which would make the hypotenuse be the square root of 2. And in a 30, 60, 90, if this was 60 and this was 30, the short side is opposite the 30. We call that 1. And the thing to look for is that the radius equals 2 times the shorter leg. And the other leg, the long leg, equals the square root of 3 times the shorter leg. And we do our best to try and disguise that, because those are the only questions we can really ask you. So we have to try and do something to make them a little harder. So let's have a look at these triangles here. Don't look at the top part. Let's look at this. I've given you just 2 sides of a triangle for 4 different questions there. Take a minute and see if you can quickly work out for each triangle. See if you've been given 2 sides of a 30, 60, 90 a 45, 45, 90, or something totally different. I'm going to give you about a minute on that. See how many of them you can spot. So on number one, we know it's not a 45, 45, 90 because the legs aren't the same length. If you can't spot that that's a 30, 60, 90, then try this. Use the Pythagorean Theorem, and we know it's a 30, 60, 90 if R equals double the short leg. Okay, so let's look at that and say we've got square root of 3 squared plus 3 squared equals R squared. 3 plus 9 equals R squared. R equals the square root of 12. Simplify that. That's the square root of 4 times the square root of 3. So R equals 2 times the square root of 3. And do you notice there? That's double X. So we know this is part of a 30, 60, 90. And this one was actually square root of 3 times X. Okay, so that was a 30, 60, 90. On this one, there is neither of them have one leg being double the other. It's the radius that's double one of them. So this is C, a different triangle. If you're not sure again, you could do x squared plus y squared equals r squared. So you've got 1 plus 4 equals r squared. R equals the square root of 5. And I hope you recognize straight away that's neither a 30, 60, 90 or a 45, 45, 90. This one, once you get into the pattern of it, you straight away see R is double that leg. This is part of a 30, 60, 90. And on this one, here, I know I see the square root of 2 on a 45, 45, 90, but it's normally the R. When the R is 2, that's normally a 30, 60, 90, but I don't get a square root of 2 on a 30, 60, 90. So let's do x squared plus y squared equals r squared and see what we get. The square root of 2 squared is 2 plus y squared equals 2 squared, which is 4. So y squared must be 2, so y equals the square root of 2. Put that in there, and straight away you notice this is a 45, 45, 90 triangle because the legs are the same length, because x equals y. Okay? Right. Before we get on, right, you've got to know your angles supremely well. So what we're going to do now is I want you to, in your notes, copy me quickly, draw a circle. Don't make it tiny. Draw a reasonable sized circle. Cut it into 4. Put a point top and bottom, left and right. Cut each quadrant in half, put a dot in the middle of each quadrant. And then just a bit to the left and a bit to the right, do another dot. Okay. Now, once you've done that, we're going to have a race. The first, don't start yet, that would be cheating. And don't have anything that you're looking at to help you. It actually slows you down if you're cheating. I want you to go around and as soon as you finish, type into chat, done. And you're the winner. There's a grand prize for it. You have 2 minutes to label everything in radians. Off you go. Turn your microphone on and yell when you're done. Let's talk you through how to do it quickly, and then I'm actually going to time myself. We'll see how I do. Okay. Now, what you need to remember is the denominators go 6, 4, 3, 2, 3, 4, 6, and your numerators in this quadrant are just pi. In this quadrant, the denominator minus 1 times pi. This one, the denominator plus 1 times pi. And in this one, 2 times the denominator minus 1 times pi. And you need to be able to do that quickly. So let's see it. I'll show you how I fill this in. And you need to practice this. You need to do it again and again and again until you can do it in about 40 seconds. I think I can do it in 40 seconds. Let's find out. On my marks, get set, go. One less. One more. Double and take off 1. Okay, I did it in 36 seconds. So see if you can get to beat 36 seconds. You really want to be able to do it in under about 40, okay? Because that means that you've really learned these patterns well, which is an essential part of what the lesson today requires you to know. And it's the central part you need to know to actually just be able to draw the terminal rays to find any of these angles. You need to know your 30, 60, 90 triangles well. You need to know your 45, 45, 90 triangles well. You need to know your reference angles, that 30 degrees is pi by 6, 45 degrees is pi by 4, and 60 degrees is pi by 3. And be able to draw a 30, 60, 90, or a 45, 45, 90 in any quadrant. So let's look at our lesson today. What we're doing in 4.3-3, there's a worksheet for this, on finding theta. You are given now, remember in a trig function, an angle goes in. This is the function. It takes an input. The input is an angle, and the output is a ratio of 2 lengths, which we tend to think of as the sides of a triangle. Sometimes a triangle is not possible. So on these questions, we're going to have to find values of theta that would make this true. How you do these problems is, remember, if we're asking you for an angle without a calculator, it's got to be based on either something quadrantal or 30, 60, 90, 45, 45, 90. The first thing you'll notice is I've covered up the question a bit there, but you have to determine the values of theta. There's normally more than one. In about 90% of the problems, there's actually 2. So we have been given the cosine of theta equals 1/2, and that's a ratio of 2 lengths. For cosine, it's the lengths x over r. We know r is never negative. So to get a cosine that's positive, if the cosine of an angle is positive, x must be positive. And that happens in 2 quadrants. You can use ASTC if you like, Angry Santa Traumatizes Children. I know cosine is positive in quadrant 1 and in quadrant 4. So we work here. Now draw 2 angles, just draw 2 terminal rays, make them into triangles by connecting them always to the x-axis. Now label the sides we know. We know that x equals 1 and r equals 2. So now we so the first thing we do is we identify the quadrants. And I know I'm going to have an answer when I find them in quadrant 1 and in quadrant 4. Because my x has to be positive. But I have to know whether this reference angle is based on a 30, 60, 90 triangle or a 45, 45, 90. So my reference angle, if the sides of the triangle are 1, something, and 2, this is a 30, 60, 90 triangle. This is us trying to fool you because a lot of people think that's going to be 45, 45, 90, but it isn't. When the radius is double one of the legs, you're in a 30, 60, 90. Your other leg here must be the square root of 3, and here be negative the square root of 3. So this angle is opposite the long leg. It's not the 30 degrees, it is the 60 degrees. Our reference angle is 60 degrees, which in radians is pi by 3. And now we just have to fill this in. We know our denominator is 3 because of the reference angle being 60 degrees. In quadrant 1, the numerator is simply pi. And in quadrant 4, the numerator is 2 times the denominator minus 1 multiplied by pi. So this would be 6, take away 1, it's 5 pi by 3. Okay. So I've done the first question there for you. I'm going to give you a minute, you try the second. So this time we've been given the sign, and we know that the sign is negative, and we know that sine is y divided by r. If it's negative, r isn't negative, y must be negative. And that might immediately tell you which 2 quadrants you're in, or you can use this, ASTC. Sine is positive in quadrant 1, and in quadrant 2, we don't want it to be positive, we want it to be negative. So these are our reference triangles. And we know the sine, the y is negative, the square root of 3. And we know the r is 2. So the third side there, we can tell just looking at it, those are 30, 60, 90 triangles, because we should know those so well. And the x would be 1 and negative 1 on that one. So this reference angle, not the actual theta we want, this is just your reference angle, is opposite the long leg, so that's 60 degrees, and 60 degrees in radians is pi by 3. And we know that our answers are in quadrant 3 and quadrant 4. So sine was negative, we're in quadrant 3 or 4, and our angle, our actual theta, with a denominator of 3, in quadrant 3, we get that denominator and make it a bit bigger, because we're a little bit, this is our angle, we're a bit bigger than a whole pi, so it's 4 pi by 3, and in quadrant 4, this angle we want is a little bit less than 2 pi. So you double that 3, get 6, take 1 off, 5 pi by 3. Now on your work, I really don't want you to, ooh, lost a pen. I really don't want you to draw those angles on, because I'm going to have to grade your work, and I really want to see clearly these triangles drawn in the right quadrants and with these dimensions. I want these numbers written on them. If those aren't on there, then I can't give you the grade for your work, which is going to be like 90% of the grade on these questions. Okay? Right. Let's give you 2 more to try. Okay. Remember, we can only ask you about things based on 30, 60, 90 or quadrantal angles. And your answer choices for your work, when we're checking your work, is we're going to ask you to say, well, when I sketch it, which of these triangles would I use? And then we're going to ask you for the dimensions of x, y, and r as well. Okay? So let's try these ones. Determine the values of theta for the following. And we've been given an inequality there that you can't just ignore it. This is going to be important. We're looking for, it's telling us it's in radians, because it doesn't go up to 360, it goes up to 2 pi. And theta can equal 0, but it can be up to, but not including 2 pi. So remember the steps. We're trying to find the input angle that would give us this output. And a tangent is a ratio of y divided by x, and it's always going to be two quadrants. When it's quadrantal, sometimes there's only one answer, but most of the time there's two answers. So think tangent is negative, so which two quadrants are we in? It's either our x or our y must be negative. It could be either of them, but not both of them. So that puts us in, we can use this, tangent is positive here, we don't want positive. Tangent is positive here, we don't want positive. We know our triangles go here and here. So you draw the ray and connect it to the x-axis. Draw the ray, connect it to the x-axis. Now label the sides of that triangle. The y is the square root of 3, the x is 3. Put the negatives on the right ones. In quadrant 2, x would be negative. In quadrant 4, y would be negative. Okay, so we have the quadrants. Now we have to recognize, are these triangles 45, 45, 90s or 30, 60, 90s? They're obviously not 45, 45, 90s, all those legs would be the same length, and they're not. So that's easy. Must be a 30, 60, 90. And now we just have to decide, is this angle here the 60 or the 30? And in your head, you're thinking, is the square root of 3 longer or shorter than just the other side, which was 3? Well, the square root of 3, that's shorter. That's the shorter leg. So this angle here must be the smaller angle. It must be the 30 degrees. So our reference angle is 30 degrees, which in radians is pi by 6. And we've identified that our answer lies in quadrant 2 and quadrant 4. And it has a denominator of 6. Think how we fill in the numerator. This is a bit less than pi, so the numerator is a bit less than the denominator. And in quadrant 4, it's not quite double it. So those are our answers there. The next question is a really interesting one. Cosecant theta is undefined, and we're going to have to find at least one angle, normally 2, for which that's true. So let's think about a cosecant. A cosecant is a ratio of which two sides? You need to know these. It's r over y. How do we get undefined? Okay, we get undefined if we divide by 0. So this means our y must equal 0. Can I draw a triangle where one of the legs doesn't exist? No. There is no triangle where a side equals 0, so this must be a quadrantal angle. Okay, if it's quadrantal, it's either going to be 0, pi over 2, pi, or 3 pi over 2. Look at those points and think, which has y equals 0? Well, there's 2 points. Now we have to say what those angles are. Well, this one is easy. That angle there is pi. And this one, there's 2 angles here. There's 0, or going the whole way around is 2 pi. Okay? So at this point, I'm thinking my answer is 0, pi, or 2 pi. But remember at the beginning, I said that you can't ignore this. Look what it said. It said theta, it can equal 0. So that's good. It's somewhere between 0 and 2 pi, so this one's good, but it cannot equal, it excludes 2 pi. The cosecant of 2 pi is undefined, but the question put a condition on us. Now let's have a look at undefined quickly. Undefined and 0. We get undefined if we divide by 0. How would we get, say we had some trig function, which was a ratio of 2 numbers. If it equals undefined, we know the denominator equals 0. What about if it was equal to 0? Then we know that the numerator equals 0. How to find if you've got something that's quadrantal? Your theta is quadrantal if either x or y equals 0, or if the absolute value of x or the absolute value of y equals r. If the radius is the same as the leg, you haven't got a triangle, you've just got a straight line. If one of the legs is 0, you haven't got a triangle, you've just got a straight line, and your angle is quadrantal. Okay? We have 5 minutes left and 2 more questions. So I'll leave you with those and I'll give you the answers in about 2 minutes, 3 minutes. That really is our favorite way to trick you, to give you, you have to realize that when the radius is double one of the legs, it's a 30, 60, 90, not a 45, 45, 90. And then the second question here, cosine is negative. Cosine is negative if that's x over r, if x is negative. So you're not in quadrant 1 or quadrant 4, you must be in quadrant 2 or quadrant 3. So now all I have to do is recognize what my reference angle is. If x is negative root 3, r is 2, again, we're in a 30, 60, 90 now. This would be, the other side must be 1. So our reference angle is actually the 30, which is pi by 6. And in quadrant 2, we'd have 5 pi by 6. In quadrant 3, we'd have 7 pi by 6. Okay, off you go, guys. You can hang on for a second if you have a question, but it's the end of class now.